Hello, this is FlippedHarber for Precalculus. In this video we'll be talking about section 4.5, Logarithmic and Exponential Equations. Our objectives for this lesson are to solve logarithmic equations, solve exponential equations, and solve logarithmic and exponential equations using a graphing utility. That graphing utility is going to be our calculator. Let's start by talking about the easy ones. If you have two exponentials equal to each other that have the same base number, in this case we have a to the u equals a to the v. We don't need to do any fancy math, we just set the two powers equal to each other. The same thing if we have two logarithms with the same base equal to each other. In this case, log base a of u equals log base a of v. We can just go ahead and set u equal to v, because that's the only way those logarithms are going to be equal, is if the stuff inside is equal. Alright, so let's take a look at a logarithmic equation first of all. We have the log base 3 of 3x minus 2 equals 2. Now, it's down to one term on each side of the equation. That's always a nice thing to do. If we can get it down to a single logarithm or a single exponential, that's always a good idea. Use your properties of exponentials, use your properties of logarithms to make that happen if you can. Now, the way that I'm going to get rid of the log base 3 is I'm going to technically put each side of the equation as a power on 3. That way the 3 and the log base 3 will cancel on the left side. Obviously nothing's going to cancel on the right side, but 3 squared isn't that complicated. So what we end up with is 3x minus 2 equals 9. Now it's just a basic algebraic equation to solve. We successfully got rid of the logarithm so that we can solve for our variable. So we add the 2 over, we divide by the 3, and we get x equals 11/9. Now, here we see a logarithm on both sides of the equation. Now we're going to go ahead and keep each logarithm on its own side of the equation, and we're going to use that power trick again. But first I have to get that 3 out of the way on the left side and that negative out of the way on the right side. Now I'm not going to divide them over, because all that's going to do is move them from side to side. I need to use a property of logarithms to get rid of them. Well, not really to get rid of them, but to just make them so they're not in front of the logarithm anymore. So what I can do is make the 3 a power on the x. Similarly, if I make the negative a power on 27, it turns it into a fraction. So now I have the log base 2 of x cubed equals the log base 2 of 1 over 27. The only way that these two things are going to be equal is if x cubed equals 1/27. Now I just take the cubed root, I get x equals 3. Okay, so here we have the log base x of 1/8 equals 3. Now this is a little unusual to see that variable in that log base location, but we're still going to use our method. In order to get rid of the logarithm, we have to make each side of the equation a power on x. When I do that on the left side, I get 1/8. I successfully got rid of that log base x, and when I put the 3 as a power on x, I just have x cubed. Well, I can solve this now. 1/8 equals x cubed. All I need to do is take the cubed root. I get x equals 1/2. Now here's an exponential equation. What we need to do is basically get rid of that 5 so that our so that our variable is no longer in the power. Now the first thing that you should try to do is write this equation so that both sides are exponential statements with the same base number. Can I turn the right side into a 5 to a power? Well, yeah, that's not too difficult. I can make 1/5 5 to the negative first power. Now I just throw away the 5's, because the only way these two things are going to be equal is if the powers are equal. Now again, it's down to a basic algebraic equation. Subtract the 1 over, divide by -2, and we get x equals 1. Now, here's an exponential equation, and my first instinct would be to move that 2 over and try to combine the 3's. I'm not going to have any luck combining the three, so I actually have to attack this from a very different direction. Now, believe it or not, what I can do is treat this like a quadratic. So let's stop and look at this. Quadratics have x, or our variable, in the middle term. Well, what if I made a simple substitution where u equals 3 to the x power? Look at that first term. If u equals 3 to the x, what's 3 to the 2x? Well, it's equal to u squared. So making this simple substitution, and I know you probably wouldn't have thought of this on your own. That's okay. That's why you're taking this class. That's why you're watching this video. We turn this into a quadratic. I can solve for the u pretty easily. U equals -2 or u equals 1. Now I make my substitution back in. U is equal to 3 to the x. And now I try to solve for the x by using a logarithm. I'll use a log base 3, and I get x equals the log base 3 of -2, or x equals the log base 3 of 1. Now, that first logarithm doesn't work. You can't take the log of a negative number. But that second one works out really nicely. Any log base of 1 equals 0. Remember, 3 to the 0 power equals 1. So x has to equal 0. Okay, here's a big, ugly looking logarithm function. Logarithm equation. What I need to do is combine the two logarithms on the left. I have a property of logarithms that says if I have the log base a plus the log base a, I can combine them to a single logarithm where the two inside parts are multiplied together. So this is now the log base a of x times x minus 2. Now I just throw the log base a's away. Once I get it to a single logarithm with the same base on each side, just throw the logarithms away. Now this is going to turn into a quadratic, and I'm going to solve it as a quadratic. I could use the quadratic formula, I could use my quadratic program on my calculator, or I could just factor it. I get x equals 4 or x equals -1. Now, which of these will work? Which of these will not? You always have to check with these logarithmic equations if you can actually plug them back in. Can I take the log base a of 4? Can I take the log base a of 4 minus 2? Can I take the log base a of 4 plus 4? Well, that one works all the way through. What about the -1? Can I take the log base a of -1, the log base a of -3, and the log base a of 3? Well, it turns out that I can't plug in -1. So that answer we just throw out, and we just keep x equals 4. Remember to always check your answers and see if you can even plug them in. Okay, so let's get to the ones that you're probably waiting for, the ones where we get to use our calculator. Now, a big tip-off that I'm going to use my calculator is the fact that they say use a graphing utility. The problems in the homework are green, so again, that tells you you're going to use your calculator. But another big thing, notice that our log bases are not the same. We have a log base 2 of x plus a log base 6 of x. I can't combine these into a single logarithm because they're not the same base. What I am going to do is use my change of base so that I can actually type this into my calculator. So I changed the log base 2 into a natural log of x divided by a natural log of 2. The only reason I chose natural log, it's something that my calculator can do and it's easy to type in. I just prefer natural logarithms because I know what's going to happen next in math, and you need to get more comfortable with the natural logarithms. My log base 6 turns into the natural log of x divided by the natural log of 6. Now you'll notice I haven't done anything to that 3. I used a change of base formula on these two terms separately. I didn't actually change anything anywhere in any term. It's just in different clothes if you want to think about it. So this isn't like squaring both sides of the equation or using some sort of operation on both sides of the equation. I don't need to change the base on the right side is basically what I'm saying. Okay, now I go ahead and I put this left side of the equation into my y equals. And what I'm looking for is where that y equals 3. So I graph it, and I use my trace button, and I move left or right until I get y equals something really close to 3. So here we see that when y equals 2.995, which is pretty darn close to 3, x equals 4.468. Okay, let's take another look at a problem like this. Again, in your book it's going to tell you use a graphing utility. It's going to be a green problem, but again, something that's tipping you off is I have a variable locked inside a natural log, and then I have the same variable not in a logarithm. So if I tried to get rid of the logarithm, I'd end up putting this other side as a power on e. So I can't really undo one change without causing another problem. Now, when you've got the variables on both sides of the equation, you want to get them to one side of the equation. So just add that x term over. This is something that I can type into my y equals. And what I'm going to look for is where it crosses the x-axis. Where is y equal to 0? So I put it into my calculator. I chose a window that's actually pretty small so that we could look at exactly where it's going through the x-axis. I hit my trace button, and I found y equals 0.020. Well, my x value is x equals 0.574. So that's going to be my answer for x. Okay, so that's it. It's going to be a lot of practice. We'll probably spend a couple days on this. Some of these problems are going to be easy, some of them not so easy. Okay? Just realize that at the end of the homework you've got some problems where you get to use your calculator. Alright, so it's time to get to work. I'll see you in class, and I'll see you online.